Hi, and welcome back to another video. And in this lesson, we're going to go over piecewise functions. So, what are piecewise functions? Well, think of it this way. You see here we have f of x is equal to both of these guys here, right? You can think of a piecewise function as a composition of other functions or one or more functions that you can have as many as you like to create a brand new function. You basically tie them in together. So one thing to note, you see right here we have x minus 4 if x is less than 2. This x is less than 2 portion is describing what the domain is. So that's an interval. You know, if x is less than 2, that means that x can also be 1, 0, -1, you know, and so on, all the way to negative infinity. It's the same deal with this one, -2x plus 2 if x is greater than or equal to 2. So you're going to see there's going to be some cutoffs here, and there may be a discontinuity somewhere. Let's just go ahead and jump right in. So how do we even begin? How do we even begin these problems? So here's your first step. You want to go ahead and make a little xy, table here, I guess. I don't know what they call it. Okay, so you have your little xy table, and with respect to the top portion, so let's go ahead and write f of x is equal to x minus 4. And we know that for this one, x has to be less than 2, right? So listen, here's the way I do it. Each and every time I'm starting off one of these, I always fill out this x and y table by respecting this domain portion right here. So whatever number that is, I want you to put that same exact number right here. So if there's a 2, put a 2. And now we're just going to simply... Oh, and before we get carried away, if you may recall from past sections, you know, this does not have an equal to underneath it, but this one does. So, you know, just for your, just for you, for your sanity, go ahead and write open, because remember, whenever we have, I can write a P better than that. Remember, whenever we have a do not equal to or something like that, like if there is no equality, we keep it open. It's an open circle. Well, it's going to be the same deal here. So let's go ahead and write with respect to this, the other x's. So x is less than 2. So going in order with, with whole numbers, what else is less than 2? 1 is less than 2. 0 is less than 2. And we're just going to go in order. 2, 1, 0, -1, -2, and so on. You know, it will keep on going, right? Basically, now that we have what our x's can be, now that we have what they are allowed to be based on this domain right here, we basically plug these numbers into the function. So we have 2 minus 4, right? So this is f of 2. You know, this notation just says to plug whatever your x is into the function. So we plug a 2 here, we get 2 minus 4, which you know is -2. So when your x is 2, your y, which you know is f of x and y are synonymous, your y is -2. And it's open at that particular point. So let's go ahead and get the other ones. You don't have to do this many points, but you know, I'm just trying to make a point to you that you want to obey this guy here. And you know, the more points that you have, the more precise your graph anyway. So you're going to see as we do more examples, we might even use less. We might just use 3 at most or something. But you always want to use maybe 5 just to make sure that you get it. But anyway, let's plug in 1. So you plug a 1 in here, you get 1 minus 4, which is -3. And you see where we're going here. You plug a 0, you get -4. You plug a -1, you get -5, then -6. So all of these points that we just got are points on this graph here. So let's go ahead and plot them. Now, at 2, -2, which is our first point, it's open. So we're going to go to 2 for x. So you know this is, you start from 0 comes 0. Then you go 1, 2 on the x-axis, right? X is 2. And then what is your y? Your y is -2. So we're going to go -1, -2 right here. And it's open. So we're just going to put an open circle right there. Let's plot the other point. 1, comma, -3. So when x is 1, y is -3. 1, 2, 3. 0, comma, -4. So when x is 0, you go down to -4. 1, 2, 3, 4 for your y. And we can plot the other ones. -1, comma, -5 would be like right here. And you can see where this is going. The more points that you have, the more precise your graph, right? So -2, comma, -6 will be like right here or something. So you can see the dots are going in this direction to -infinity for your x, right? It's going to the left. So all you do is start from that open circle, that first point that you made, you just go ahead and make a straight line going through all those points. So it should look something like that. So guess what? We're done with the first portion. We have everything we need for this top portion here. We're done with it. We already have our points. We found our x's and y's. Let's go down to the other function and do the same exact thing. So, you know, first things first, make your XY table. And in the next example, we're going to do it a little bit differently. And I'm going to show you the erasing method. You'll see what I'm talking about. But right now we're just plotting. We're doing a plotting method. I think this method is much more easier to grasp. That's just my opinion. Anyway, so remember what we did. Right here, x is equal to, the first number that you put is whatever number that you have here, which is a 2. And it's equal to, right? So let's go ahead and write the word closed. You know, that's just a little note for us to say that this is a closed circle. So, obeying this with respect to this domain here, what is x allowed to be? X has to be greater than or equal to 2. So we already have the 2 here. We know it's closed, so that satisfies the equal to portion. But what else can it be? X is greater than 2. So what is greater than 2? 3 is greater than 2. 4 is greater than 2. 5. Now, you just want to make sure you go in order. 6. So let's go ahead and figure out what the corresponding y values would be. So all you do is plug in whatever your x is into the function itself. So for this one, f of 2 would be equal to, you know, this is -2 times 2 plus 2. -2 times 2 is -4. -4 plus 2 is -2. So when your x is -2, when your x is +2, your y is -2. And we're just going to keep going from there. So let's plug in a 3. You plug a 3 here, that's -6. Well, let's go ahead and, so you can see it. All right, plug a 3 here, that's -2 times 3 plus 2. That's -6 plus 2, which is -4. There you go. That's your y. So let's plug a 4. We can do this in our heads. -2 times 4 is -8. -8 plus 2 is -6. And there's a little pattern going on here. These are linear lines, right? Like the straight lines, because this is to the first power. Remember that? So you can, it's safe to say that you can just keep on going in order. 2, 4, 6, 8, 10, negative. So let's go ahead and plot this. So we have 2, -2. But check this out. Isn't 2, -2, isn't that the same point as this one up here? At first it was open, right? But now we have it closed at that same spot. So listen, whenever you have an open circle and a solid closed circle on the same area, the whole thing just becomes closed. You can imagine just filling in the hole with cement or something. I don't know. Like, you're not taking it out. If you were to get another open circle from like another part of the piecewise and it's open above your solid again, listen, it stays solid. Once it's solid, it stays defined right there. Anyway, 3, -4. So 1, 2, 3, and then -4 for y. 1, 2, 3, 4, somewhere right here. 1, 2, 3, 4. All right. Yeah, right there. Then we have 4, -6. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So like right there. And you can plot your other points. You know they're gonna align quite well. So how about we just go ahead and extend this to go through all the points that we know are going to be there. And remember, it goes on forever and ever. Okay, so this right here is the graph of this piecewise function. And you see all we had to do is make an X and Y table. We had to respect this though. You can't just put, you know, any numbers here. It has to respect this. Always put whatever number that is, put it here. And put it here right at, you know, the X and Y table. And you just go from there. X is less than 2, so put a 2. And what else is less than 2? 1, 0, negative. And please make sure you go in order. You don't want to start jumping around and say 1 and then -2 and then 0. You know, just go in order. You know your number line. Okay, so that's it. That's all there is to it. Here's the graph. And they may ask you something like, is it continuous? Did I just spell continuous wrong? Whatever. I'm a mathematician, not a English major. Anyway, continuous. All right. Anyway, yes, the answer is yes. So the reason why is because take a look at this graph, right? You want to start all the way from the left to the right. If you were to draw like a dotted line, or, you know, if you were to retrace this, would you ever be required to take your pencil off of the graph? It's still solid, still solid. It's still solid here, right? Still solid, still solid, still solid. So you know what? This thing right here is considered continuous. So is it continuous? Yes, for this particular graph. And that's all there is to it for piecewise. We're going to go ahead and do another example. So let me get that right quick. I am at the mercy of you students because the only examples I get come from you guys. So, yeah, please send me more questions in the future, please. All right. Anyway, we have f of x is equal to, this is going to be a little interesting. We have 1 plus x squared if x is less than 1. And then we also have 9x minus 7 if x is greater than or equal to 1. So let's save some room here. We don't need all that space. Okay, so let's do what we did last time. Now, one thing of note, we have 1 plus x squared. That is not going to be a straight line. If you recall the graph of y equals x squared, or you know, f of x equals x squared, same thing, right? Y, f of x. It should look like this, like a parabola, like a U shape. So if you know that it's supposed to look like a U shape, you want to keep that in mind because that's going to be important. You don't want to just make a straight line and then get the, you know, get the question wrong. This thing has a curve. It has a, remember right here on a parabola, we have this little, they call them peaks and valleys, max and mins, you know. We have a middle parabola right here and it's called the vertex. Right? So you always want to make sure that you include that vertex, or you consider the vertex when you're doing these. That's just to make sure that you understand the curvature and the layout of the graph itself. So let's go ahead and begin this. Perhaps we'll be lucky where we'll get that nice perfect curve. But anyway, let's go ahead and start by making an XY table. Okay, let's go ahead and put the same number down. Oh, and we're working on f of x is equal to 1 plus x squared. And this is if x is less than 1. So let's go ahead and put the 1 down. Now specify if it's open or closed. There is no equal to underneath here, so this thing is going to be open. So we're just going to write open right here. Let me make sure you guys can see that. Yeah, you can see it. All right, good. Okay, so it's going to be open. And let's go ahead and obey this domain right here. X is less than 1. So what else is less than 1? Going in order. So we have 0. And you know what I'm, just to go on a little tangent here for a second. Do you know what I mean by going in order? So you have your fancy number line here, right? Let's say 0's in the middle. What's going to be to the right and left? We have 1, 2, 3. We have -1, -2, -3. So when I say go in order, I mean go in order of the number line. Okay. So for example, we started here at 1. So if you're starting at 1 and it says you want to go in order, we're going less than 1, we should be traveling this way. We're going to go over to 0, then -1, then -2, then -3. And that's exactly what we're going to put here over here in this section. So, when I say go in order, I mean go from least to greatest or greatest to least. Okay, so now that we've established that, what else is less than 1? 0 is definitely less than 1. What else? In order, -1, -2, -3, and so on. So let's go ahead and plot these points to get our corresponding y. So let's plug 1 into here. You plug a 1 there, you get f of 1 is equal to 1 plus 1 squared. 1 squared is 1, 1 plus 1 is 2. So that's your y. When your x is 1 for this function, your y is 2. Let's plug in 0. That'll be f of 0 is equal to 1 plus 0 squared. 0 squared is 0, 0 plus 1 is 1. Now, remember, it has an x squared, so you don't want to say, oh, okay, I'm just going to go in order and say this is 2, 1, 0. No, whenever you have an x squared, remember, it's a U shape. So it's a parabola, so you don't want to just assume. You want to get as many points as possible. So let's go ahead and plug in -1. So 1 plus -1 squared. -1 squared is 1, 1 plus 1 is 2. All right, we got that. And we have -2. Let's go ahead and plug -2 in. Oh, we can do that on our heads, right? -2 squared is +4. +4 plus 1 is 5. Plug in -3 in. That'll be -3 squared, which is +9. 9 plus 1 is 10. I think it's safe to say that we got it. So let's see if it gives us a nice parabolic shape. So the first point is going to be open at 1, 2. So we have 1, 2, and it's open. So just go to 1, 2 and make an open circle just like that. All right, what else do we have? We have 0, 1. So 0, 1 is right here. We have -1, 2. Oh yeah, we nailed it. And you're going to see why. We have -2, 5. 1, 2, 3, 4, 5. 1, 2. And then we have -3, 10. So 1, 2, 3, and then all the way up to 10. So starting from that first plot that we did, the first point, 1, 2, you want to start from there and just follow the rest of the dots. Something like that. And look, isn't that a parabola? Like if this thing were to keep going on the other side, wouldn't it be like something like that, right? Notice that this part over here is actually cut off. We didn't include that part because x had to be less than 1. Here's where x is 1. Anything less than 1 is what's going to be solid. But over here, 2, 3, 4, 5, it is not solid after that point. So we would not include that. We have to start wherever we said we were going to start here at whatever this number is at 1. So, and this is as hard as it gets. Whenever this is as tough as it gets. Whenever you have an x squared, you just want to account for the curviness of it. So if you can grasp that, you can get any one of these piecewise functions. And I didn't forget. I said I was going to do it a different way, and we were going to actually graph it and maybe erase what we can't quite put there. So here's what I mean. So listen. You can go ahead and do another XY table and put a 1 if you prefer that. It's nice and clean. You'll get your answer. Or you can take the knowledge that you know, your knowledge of graphing, your y equals mx plus b stuff. If you've mastered that, I say use it. So remember the form y equals mx plus b. So remember, you always start where your b is. In this case, it's going to be -7. So 1, 2, 3, 4, 5, 6, 7. There's your first point right there. And then according to this m, you know your m is whatever's in front of the x. So that's 9/1. And remember, you can say to heck with this, to heck with this technique if you prefer to do the table way. And we will do the table way, and you're going to see that it is basically the same thing. So remember, your slope is 9/1. So doesn't that mean you go up 9/1? Remember? So rise over run, up 9/1. So from this first point, from the y-intercept, you go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over 1. So it's actually going to be on that whole area right here. But let's just keep on going. Up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then over 1. So I'm going to go ahead and make like a solid line going right through there. So this is the graph, but mind you, this is the graph when we do not pay attention to this x is greater than or equal to 1 portion. So how do we account for that? And where is it? Where is it even going to occur? So when x is 1, isn't that right here? And it's actually equal to, so listen, if x is not greater than 1, what you're going to do is erase everything that's less than 1. So here's 1 for x. Anything that's to the left, we're going to have to erase. So the erase, you know, sometimes depending on your course, they make you do the erase method, which is kind of like not too good, in my opinion. But that's exactly what we're going to do here. So if it's less than 1, we're going to have to get rid of it because we need x is greater than 1. So we're just going to erase everything that's on this side here. Now, question, is it open or solid here? It's equal to 1. So we can go ahead and fill in this hole that we had before. So you should get something like that. This is the graph. We're done. We had to use, well, we didn't have to use, but if you're familiar with y equals ms plus b, you just graph whatever the function it gave you and erase whatever should not be there. So if you know x is greater than 1, you better erase everything that's less than 1. And that's how we solve these. I'm gonna double back, and I'm gonna stick to the method that we were using before, because I don't know, that method has really grown on me over the years, and I think students appreciate that more. So let's go ahead and change that back into an open circle from our previous step. Let's see, this was 1, 2, right? So 1, 2, that's open right there. Okay, so we're gonna do the good old trusty XY method. You can choose which one you like the most. The y equals ms plus b stuff works well with straight lines or linear lines, but it will never work with something like 1 plus x squared. So listen, I want you to this is just me throwing my little 2 cents in. I highly recommend you do the table method, okay? So with respect to this, whatever number that is, put it here. Is it open or closed there? It's going to be closed, and it's closed because of the equal sign. So obeying this, respecting this, x is greater than 1. What else is greater than 1? 2, 3, 4, 5, right? And let's go ahead and plot in these numbers, plug in these numbers. We can do it in our heads. 9 times 1 is, you know, we're plugging in the 1, right? 9 times 1 is 9. 9 minus 7 is 2. 9 times 2 is 18. 18 minus 7 is, wait, am I tripping? No, 18 minus 7 is 11. Yeah, the numbers get pretty big, right? If you plug a 3, you get 27 minus 7 which is 20. So that's out of bounds, but it's okay. We have what we need. We have 1,2, which is a solid right here at this point. So we're going to fill it in. And then we have 2,11 way up there. And if you remember from the last example, that's exactly what we got last time, I believe. And we're just going to make a straight line going through that point. And let's put some arrows there to show that it goes forever and ever. I think this way right here is much cleaner, much more easy to grasp. So, all right, that's it. If you have any questions, you can ask them in the comment section. That's all there is to it with Piecewise. I think 2 examples is enough. Thank you so much for watching. I hope this was helpful to you.